Assalamualaikum and hi everyone. We will continue chapter 10, application of differentiation, lecture 2 of 2, part 2. Example 2. You have been asked to design a 1 liter oil can shaped like a right circular cylinder. The question: which dimension will use the least material? Okay, so this is an application of second derivative test. So you need to understand what is the information given. You need to imagine, you have to draw. Okay, so the information given is you are given a 1 liter oil can shaped like a right circular cylinder. For the diagram given here, you can imagine that the can is filled with a 1 liter oil, means the volume for a right circular cylinder is given as 1000 centimeter cube. Okay, that is equals to 1 liter. So what is the formula for volume for a cylinder, right circular cylinder? So the formula for volume is equals to the surface area for the circle here is the surface area is equals to pi r squared. Then you have to multiply with the height here. The height is h. Okay, therefore pi r squared h is equals to 1000. Okay, then you can simplify. Maybe we will get h as a subject in terms of 100 over pi r squared. Okay, so we will use this equation later. Okay, the question asks which dimension will use the least material. From the question we can understand that we want to find out what is the least material, means the surface area. So what is the dimension for you to get the least minimum? Okay, so to get the minimum surface area. Okay, so I will use surface area as A. Okay, so the question asks what is the dimension here. Dimension maybe what is the value for r or the value for h, that is the height, and r means the value for the radius, for you to get the minimum surface area A. Okay, so what is the function that you want to optimize here? What is the function that you want to get the maximum or the minimum? So we want to get the minimum surface area. Okay, so A will be the function that you will optimize. So you must write what is A in terms of R and H first. Okay, so you have to write what is A as a subject in terms of R and H. So this is the function that you want to optimize. Okay, so you have to imagine, you have to draw the diagram. Okay, so for a right circular cone, we have a shape like this, where you have two circle ups and down here. So what is the surface area for the circle for up and down here? Okay, so the surface area is equals to pi r squared, and we have two circle, so you need to put 2 in front. 2 pi r squared. Then when you open the circle, you unroll the circle, you will have the shape of rectangular here. Okay, you will have a shape of rectangular, and at the top you will have a circle, and at the bottom also you will have a circle. So the area of the rectangular is, the height is h, the height of the circle is h, and the length of the rectangular is actually equals to the circumference of the circle, that is 2 pi r. Okay, so this is the area of the right circular cylinder in terms of r and h. Okay, so you need to simplify this. I want you to write a only in one terms, either in terms of r or h. Okay, so from our previous result, we already have h as a subject. In terms of r, there is h is equals to 1000 over pi r squared. Okay, so we will substitute h into the equation here. I call this one equation number 1. Okay, therefore a, the surface area, is equals to 2 pi r squared plus, I will substitute h with 1000 over pi r squared multiply with 2 pi r. We will simplify to get a is equals to 2 pi r squared plus pi, we cancel with pi, 1000 times 2, you will get 2000. R over r squared, you will divide 2000 by r. Okay, then we will simplify to get 2 pi r squared plus 2000 over r can be written as 2000 multiply with r to the power of -1. Okay, you have to simplify because after this we will differentiate a with respect to r. Okay, so therefore our equation, I will write it again. A is equals to 2 pi r squared plus 2000 r to the power of -1. Now to get the minimum surface, you have to differentiate a dA dr. Then you will get 2 times 2, we get 4 pi r plus 2000 multiply with -1 r to the power of negative 1 minus 1, negative 2. Then simplify to get 4 pi r minus 2000 over r squared. Okay, then to get the minimum surface area, dA dr you have to equals to 0. This is to get the minimum surface area A. Okay, therefore you will get 4 pi r minus 2000 over r squared equals to A. Therefore you will get 4 pi r is equals to 2000 over r squared. Okay, then we continue. Next page, you will get r cubed is equals to 500 over pi. Therefore, r is equals to 500 over pi and to the power of 1 over 3. Okay, you can check the value by using the calculator, and you will get r is approximately equals to 5.42. Okay, this is the radius of the cylinder. When r equals to 5.42, what is the value for h, the height of the cylinder? You need to find h. Then we will substitute r equals to 5.42 into the equation of the h. You will get h is equals to 1000 over pi multiply with 5.42 squared, and the value is approximately equals to 10.84. Okay, so we have already get the dimension that will make the least material, or the dimension that is r and h that will make the surface area minimum. Okay, so the surface area minimum when r equals to 5.42 centimeter and h is equals to 10.84 centimeter. Okay, that's all. Thank you. Now we will do the second derivative for d squared a dr squared, but I want to write first dA dr is equals to 4 pi r minus 2000 multiply with r to the power of negative 2. Okay, therefore we differentiate for the second time. D squared a dr squared is equals to 4 pi is a constant, so the answer is 4 pi. Pi is a constant also, so minus 2000 multiply with negative 2, bring in front, r minus 2 minus 1, you will have minus 3. And simplify to get 4 pi. Minus minus, we have plus 4,000 over r cubed. Okay, so now we will substitute the value of r equals to 5.42 into d squared a d r squared. Now I will substitute r equals to 5.42 and the answer will be 4 pi plus 4,000 over 5.42 cube, and the answer will be more than 0. There is something positive value. When you get here positive means you will have the minimum surface area. Okay, so now the second derivative here will support the result that you get before, that is when r equals to 5.42 and h equals to 10.84, then the surface area is minimum, because we managed to get d squared a dr squared is more than 0 here. Okay, so this is the conclusion. R equals to 5.2 and h equals to 10.84 centimeter. Thank you.